guess we can get started. Um, yeah. All right. Welcome everyone to Advanced Track workshop number 7. We're doing a guided project today, which is going to be quite different from all our other workshops this quarter. So yeah, as Sudhanshu said, we'll actually be creating our own CNN model to classify classify pictures in a data set with almost 60K pictures. So it's going to be quite interesting. You'll be able to apply kind of all the skills that you learned during the CNN workshops and the PyTorch workshops. So it's going to be fun. Anonymous feedback, as always, is on the slide as well as in the chat. And yeah, let's get started. Before, yeah. So, like as I mentioned, PyTorch workshop is going to be applied here, and we're going to learn a lot of practical skills, specifically creating a CNN model with PyTorch. And yeah, we'll just get straight into it. Before we do that, I'm gonna hand it over to Frank. He's gonna talk a little bit about the projects application for the projects team in ACM AI. So yeah.
Hi everyone, my name is Frank and I'm also an ACM AI officer, and I'm here to ask you guys to apply, or if you want, to apply to ACM's or ACM AI's spring projects. So if you don't know, every winter and spring quarter, we offer this thing called projects in which you get to work with like a small group of people on some real world deep learning problem. And over like the course of a quarter, we'll guide you through like every step of actually building a deep neural network to solve that problem. Um, and yeah, this quarter we did this project called, which you can see on the left, called cost of a leaf disease classification. In that project, we basically took a lot of images of these cost leaves, as you can see here. And these leaves are like one of the biggest producers of the carbohydrates in Africa. And we tried to detect whether or not like these pictures of leaves had disease or not. And if the leaf did have a disease, we tried to also classify what disease that leaf had. Next quarter, which or spring quarter, we're going to be offering this project again, but we're also going to be offering at least one other project. And at least right now, or tentatively, that's going to be this humpback whale identification project, in which we try to take like the tails of humpback whales and you try to like classify that as, or you try to identify this individual humpback whale whose tail that is. So it's kind of like facial recognition for humpback whales, which I think is pretty cool. So if any of that sounds interesting to you, you can learn more. There's an FAQ which on the screen, and you can also apply. But one thing I really want to stress is that if you're attending advanced track, which is all of you guys, we're gonna you'll automatically be accepted into projects. So it's less of an application and more of like an interest form to see like how many people actually want to do projects next quarter. So yeah, if you guys have any questions, I can answer them right now. But sorry, I know I talked really quickly, and if you want me to repeat anything, I can talk about it or say it again.
What's the time commitment like for projects?
Yeah, it's a great question. So there's a more detailed answer on the FAQ, but this quarter we've basically just meeting twice. We've been meeting twice a week for 2 hours each, and most of the teams have been doing like at least like 90-95% of the work in those meetings. You will have to spend some time like outside of it, like just checking up on your models and things like that. But I think like the total time commitment is around like 4 hours a week.
Okay, thanks.
Any other questions? If you're not really sure like whether or not you want to apply, definitely still feel free to fill the form out, because again, it's more like an interest form and it's not like binding or anything. But if you're still like on the edge, another projects officer will come over next week to remind you guys so you don't forget. Oh, I think I forgot to make it public. Thank you for letting me know. I'll fix the link afterward, but you should be able to take a look at it after. All right, cool. I'll hand it back to Adithya or the other workshops officers. Thank you.
All right. Thank you so much, Frank. Yeah, cool thing about projects is once you're done with advanced track, like you have pretty much all the necessary knowledge to thrive in the projects team and be able to apply what you learn for all these projects. So definitely give it a shot. Yeah. Moving on. Yeah, one other quick announcement from the outreach team at ACM AI. So ACM AI's outreach team just began season 2 of the You Belong in AI podcast. So it's essentially a podcast about diversity within the field of AI in both an academic sense and as well as the industry. It features like a diverse and inspiring like set of leaders in the field of AI who like discuss their backgrounds, their work in AI, and the importance of inclusion and diversity in AI out there, um, which is really interesting. So if you're interested in learning more about in general AI as well as potentially pursuing a career in the field, you can listen to all the podcasts through the link on the slide. And You Belong in AI just started season 2 last month. And I believe it's season 1 started like last year. And there are already a few episodes up. So there's definitely a lot of content already up there, ready to be listened to. So yeah, that's You Belong in AI. Cool. I think that's it for any announcements. Let's get into it. All right, so let's talk about the project we'll be doing. So, so like as we mentioned, it's going to be creating a CNN classifier, and we'll be classifying pictures from this data set called the CIFAR 10. It is called 10, I believe, because there are 10 different classes of images in this data set. And we'll get a little bit more into the data set like later on in the slides. So the way you go about this project is, similar to how we went with the PyTorch workshop last week. You can start up your content environment that we set up last week and kind of create a Jupyter notebook there and begin coding. You should already have everything, all your libraries installed, like Torch, PyTorch, and Torch Vision, all that sort of stuff. And yeah, there's going to be a lot of overlap in the code that you did last week for the PyTorch workshop, as well as this workshop today. So feel free to like check back on the code that you did in the last workshop. Let's see. All right. Documentation is super important. So yeah, so last week we did implement a feed over neural network. But this time around, we're going to be implementing a CNN, which is going to be fairly different. We're going to need to have to implement convolutional layers, pooling layers, deciding on kernel sizes, sizes of input and output channels, all that sort of stuff. And the syntax for that can get confusing if you don't really know how to like go ahead and code it. So having the documentation open, really good idea. It's pretty much going to be your best friend. So honestly, I would suggest keep a tab open. Go to the link on the slide that you see right now. Just keep the documentation open. So whenever you need to look up how you want to do a particular thing, maybe you want to add another convolutional layer, or you want to slap on like a fully connected layer at the end of your like convolutional and pooling layers, you can do that. All you got to do is like look it up on the documentation. So really recommend that you just take a look to it, glance it. It's also really good, really well made. So Yeah, good stuff. Yeah, so here's a few more links for different pages on the documentation that will be especially helpful today. So you can see we're doing, there are pages on convolution layer, masculine layers, linear layers for feed forward, and all sorts of stuff. So can't stress this enough, documentation is gonna be super important. It is going to be pretty much your first point of contact when you want to do something or anything in today's project. So yeah. All right, let's talk a little bit about the CIFAR 10. It is a data set with almost 60,000 images and specifically colored images. So different from the mnist data set, which were only grayscale images. So the mnist data set only had, you can think of it as a one input channel because there's only one color channel available. But since you have color images, you're going to have 3 different channels for RGB, which is why a CNN is going to come in especially useful right now. There are 10 classes of images in this data set. So some of the examples for these classes are going to be like trucks and horses and cats and dogs and airplanes. I don't remember everything off the top of my head, but there's a pretty wide variety of classes, 10 classes. Yeah. Anything else? Yeah, so the images, so since there are 10 classes, there's about 6,000 images for each class. So you're not like, training a model to identify one particular class or one particular type of image more like better than other images. It's a pretty even split between all the different classes. So yeah. You don't need to download this dataset separately. It's available through Torch Vision, which is how we imported our mnist dataset last week. So feel free to look over the code for importing the dataset, the mnist dataset from last week, and applying it here because it's going to be pretty similar. And of course, documentation is always there to help you as well. So yeah. All right. We are going to be here, so we're not gonna just be like, we're not gonna like leave you guys to it. We will stick through until everyone is pretty much done with the project, or if you've hit the time limit, in which case you can always hop in to office hours and we can continue helping you guys there. You won't be, we're not going to throw you into the deep end immediately. We have a skeleton notebook ready where we've put in essentially code structures, not the exact code itself, but like the overall structure of what the code should look like, as well as a whole bunch of comments to kind of guide you guys in the right direction. We also have rough estimates of the amount of time it'll take you to actually implement a certain section of the code for the CNN model in different like cell blocks or cells, I guess, not cell blocks, but yeah, cells in the notebook. So that should pretty much be a guide for you to like, that should tell you like if you're on pace or not. And don't worry if you can't figure something out. As I said, all 3 of us are still going to be here. We're here to help you. We're also going to be setting up another breakout room only for debugging purposes. If you guys want to like maybe share your screen, one of us can hop in with you in that breakout room and kind of like deal with any issues you have. And yeah. So yeah, so the workshop is meant to be interactive. So it's going to be less of us 3 lecturing and more of like a sort of constant stream of communication. And we can kind of like answer your questions about CNNs or how you implement something in PyTorch. And yeah, it's going to be a little bit of a different workshop, but at the end of it, you should have been able to create a CNN model, which is pretty cool. Yeah. Yeah, questions, breakout room, anything you want to share your screen, blah, 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 all that sort of stuff. Cool. So yeah, here's the best way to get started. Take a look at maybe the CNN workshop slides that we did like, I don't know, like 3 weeks ago or something. Take a look at them. They will be helpful to you because you will need to kind of set your own hyperparameters, like the number of convolutional layers you want, max pooling layers, kernel sizes, all that sort of stuff. So if you kind of want to get a refresh on what those were, those slides are going to be helpful. And the PyTorch workshop, obviously, because the code and the syntax. Yeah, I think that's pretty much it. The skeleton code is on the link on the slide. So go ahead and download that notebook and get started, I guess. So I guess before that, does anyone have any questions?
I have a quick one. Would we just make like a new environment in Conda?
No, you can kind of work off the environment that you set up last week for the PyTorch.
Yeah, I think it should work for this workshop as well.
Yeah.
Okay, cool.
Alrighty. So if there are no other questions, you can go ahead and get started. Jenson, you'll be sharing your screen, right?
Yes.
All right, perfect. Take it away.
Oh, wait. All right, so I'm just gonna save a copy in my drive. Alternatively, you can also download the notebook and run it on Jupyter. But I think I'm just gonna do it on Colab.
Yeah, Colab works too. So if anyone's Conda environments are not working or are being dumb, feel free to do the project on Colab as well.
Yes, first I'm just gonna import all the packages. All right, so if you're doing this on Colab, here's a cool trick that you can do to speed up your training process. So go under Edit, Notebook Settings, and then choose GPU as your hardware accelerator. And let's now run this cell. So here's my confirmation that I am running on one of the GPU from Google. So that's pretty neat. And yeah, I think the rest is just the actual guided projects. So this is actually a great opportunity for you guys to apply what you have learned over this workshop series. And yeah, I'm really excited to see what you guys can do. Let's see, do you have any questions? Okay, never mind.
Yeah, and try to give us some indication when you're done with the first cell so that we know when to move on. If anyone's having any trouble, we can pace ourselves according to how you all are doing.
And be sure to ask questions because that's what we're here for.
Yeah, and we have a breakout room set up. So in case you have any questions, just shoot one of us a message and we'll hop in the breakout room with you. If you have any specific questions. But of course, feel free to ask questions here as well.
Should we do a class, like a custom dataset class, like in the last workshop?
Actually,
So you can
that's
think,
not strictly necessary, but you can do it if you want.
yeah, the reason it won't be necessary, right, is because the Safar 10 dataset is in that Torch Visions package. So if you think about it, we did two different things last workshop. So maybe one of them could be more helpful in this case. So you can check out last workshop as well. The way we loaded the mnist dataset, you do something similar for this one.
Okay, sounds good.
Also, be sure to like let us know once you are done with this section so that we can kind of like um, fill the notebook in and then move on to the next section. So yeah.
Yeah, basically, if everyone's done with this cell, I'm just gonna go through this together with you guys.
Yeah, but we'll give a little more time. But yeah,
Yeah.
but when we say section, we mean cell. So don't
Yeah.
try to complete the entire thing first.
Yeah, just to make sure like you guys are on the right track.
Yeah. So we have a question on the chat, right? Out of curiosity, if we have our own data, would what format would it have to be in to use it? Would it just be a CSV? So often the data sets, yeah, it's all good. Yeah, so often the data sets are in the form of CSVs, and that's more for like what data you're given, right? We as the ML engineers don't really have control over how the data comes in, but yeah, it's mainly a CSV. In that case, you want to load it in using pandas, and once you do pandas, then you can implement the Russell pipeline like we've shown over here. But yeah, again, in this case, it's completely built in the Torch Visions package, so you just need to download from there. So we have a question. Are the images supposed to be super blurry? The answer is yes. So the way the data set is here, the resolution is very low. So I think it's about 32 by 32 pixels, something like that. So there's not much resolution. And the reasons like that is because it would be pretty much impossible to train on our machines otherwise. We can't train a 48 megapixel image just yet. We need a huge amount of memory. So yeah, they would be blurry. And yeah, once you all are done with that cell, just give us some indication. That would be really helpful. Like, I don't know, maybe a reaction or something.
I think I'm done, but I don't know if I did it right.
So I think the best way to test it is just go on to the next cell, and we have like a little checkpoint for visualizing a sample, which will, if it runs, you're golden. But
Yeah, I
that's
think
great.
if you can see the images, I think you should be good.
So okay, I think a couple of people who are done. Okay, let's give it like a minute more, and then we can
Yeah,
give
I'm
it a
gonna
shot.
wait for like a few more minutes.
Yeah, and then remember the PyTorch workshop is your friend. It's a slightly different structure from that, but a lot of the same syntax. The nice thing about PyTorch is the nice thing about Python is if you change the name, you pretty much guess the right function. So yeah. And yeah, remember, so if you're like, you're chilling, you're way ahead, please feel free to go ahead and do the other cells. Hopefully the notebook has enough structure for that.
Yeah, if any instructions are unclear, like feel free to let us know. We can like clarify.
Yep.
Also, a time limit thingy that's supposed to be like a guideline, so don't feel stressed about it. It's totally fine if you can like finish it in the given number of minutes. Okay, we have another question. So what is the num worker hyperparameter? Okay, so which cell are you referring to?
It's not in the code, but I just searched up because it said feel free to mess around with the hyperparameters. So I just searched up some common hyperparameters, and I saw that there was something called num workers, and I wasn't sure what that was referring to.
Oh, you mean for the data loaders or which object?
Right. So it's a hyperparameter for the when you load the data set, right? And it's, I guess, a more advanced hyperparameter. It pretty much tells you workers refers to how many processes you have, and it's going to say like how many processes you want to load this thing onto. So the best place to like figure out all this stuff is the actual documentation again. Like I said, PyTorch has like a one of the best documentations I've ever seen in my life. So it has, I just looked it up right here, and it has the num workers hyperparameter mentioned. But yeah, you don't have to worry about that. But
yeah, apparently it has to do with the number of threads
the number
that you want
number
to.
Of threads.
Yeah, number of threads that you want to be loading your data set with. So parallel programming, all that fun stuff. Wonky stuff.
Yeah, I think you can just like, I guess, use the default value, which is 0.
Yeah, it's also worth knowing that like we don't know all these answers off the top of our head. We just Google PyTorch, num workers, like Torch Vision, and it pops up really beautifully. So that's definitely a nice thing about this documentation. I think, Jenson, we can probably implement the first cell.
All right.
It's been like 10 minutes. Yeah.
All right, cool. So I think all you do here is you do torch vision dot datasets like we did last time, and then instead of mnist we do safar 10. So it auto completes. And then I'm just gonna load this into, I guess, /safar10, but you can call this whatever you want. And then the transform parameter is transform to tensor. So we're basically just turning this data set into a tensor. And then we're gonna also set download to be true. Okay. So for a test data set, it's very similar to the train data set. So I'm just gonna copy and paste. However, there is like one slight twist. So that I'm gonna set the train to false. And yeah, hopefully it should work.
Yeah, so if you guys don't remember, setting train to false essentially means Torch Vision will be returning the testing data set for Safar 10. So yeah, but yeah, you don't have to mention it for the train data set because it is by default true for this
Yes.
function.
Yeah. The next cell is just creating a data loader. And once you do that, you should probably go into the next cell as well and try and visualize some pictures. That should be a nice visual for you all.
Yeah, so
And
if
we
you're
pretty
running on
much,
Colab,
sorry.
you can actually like see the Safar 10 data set in your temporary files. But like just keep in mind that like all these files here will be erased after this runtime has ended. So if you want, you can download the data set to your computer, but I don't think that's necessary.
Yeah, probably easier ways to do that than through
Yeah,
Colab.
You can just keep like, I guess, running this cell if your runtime has disconnected.
And yeah, please give us some indication when you're done as well. Like a message in the chat or something would be good so we can keep track. Like done, return, exit, status equals true, something like that. Yeah, it would be helpful.
Exit 0, bro. Successful exit.
Good stuff, good stuff. Someone got a picture to show
Right.
up. That's awesome.
Fantastic.
Nice. Yeah, if you have a picture, like if you can see a picture, you can feel free to start building your model. Hopefully the instructions are clear, but if you have any like thing that you're confused about, then feel free to let us know. We're just gonna wait for a little longer here.
Cool. How's everyone doing? Are you all able to find the relevant line of code? Completely lost? We all good?
Yeah, I think we did something very similar last workshop. So
Yeah,
think-
very similar.
yeah, I think looking at the notebook that we have for last time would be really helpful.
Yeah, and the link for that is in the current workshop slides, so don't forget that.
Yeah, I think it's this link.
Mhm.
Let's see.
Don't give it the answers, Jenson. Let's close the notebook.
No, there's nothing in the beginning.
Okay, nice. Let's give it a minute or two more, and then we can fill in the next couple cells. Okay, status check. Is everyone good? Or does anyone need any more time?
Yeah, give us like
Yeah.
a reaction if you're good.
Yeah, we got a thumbs up. We got a couple of thumbs up.
Yep,
I think we're good to go.
thumbs up. Okay.
Yeah.
All right. So yeah, this is, like I said, it's really very similar to what we did last time. So the way to do it is to go to torch.utils.data. So this is where the data loader class is being stored. And so, yeah, as you can see there, there's a little documentation here. So the first parameter is just our data set. So for the train loader, I'm just gonna input the train data set. And then second parameter is batch size. So this is a hyperparameter that you can actually potentially experiment with. So if you pick a different value of batch size, you're gonna get slightly different results in your training. But I think I'm just gonna pick some number like 16. I think that's a pretty good number. And also gonna set shuffle to be true. So this means we're gonna be shuffling our data sets when we're loading it. So that's I guess a pretty standard thing to do. So for a test loader, it's very similar, except you change the data set parameter. Yeah, that's pretty much it. Any questions?
I think we might be able to go into the next quick cell as well, since it's only a
Yeah, is everyone
of
done
code.
with the next cell?
Okay, I think we're good to
thumbs
go.
up. Yeah, so this is actually so all we do in the next cell is basically just convert our train loader to an iterable object. or iterator. So we do iter and then train loader. And we get like a very blurry image of a car. So the cool thing is like if you run the cell again, you'll get a different image. So you can keep running the cell to like, I guess, look at a bunch of images in the train loader.
Yep. It's worth looking at the size of the image as well. Notice how the axes have like 32.
Yeah,
it's better to actually inspect it.
32 by 32.
Yeah, so we have 32 by 32, 30 by 32 range. So yeah, so now you can go on to the actual meat of it, which is building your CNN. And this is where what usually takes a little bit more time, because you're gonna have to keep revisiting it, keep tuning it, keep changing it. So start off with something simple, and we have like, what do you call it? A template in the markdown cell above. So it goes to conv, max pool, some stuff in the middle, which we're not going to talk about, and then it goes to fully connected and then to an output. So structure it in this manner and experiment with different architectures. And this is where the documentation really comes in handy. So go to the PyTorch page for this particular function and try and figure it out.
I think the beauty of implementing a CNN is like, there's so many ways that you can compose like all these different layers that you have together. So there's definitely a lot of possibilities here. So feel free to explore them. I guess a good place to start would actually be looking at this article. So I think, okay, let's wait for it to load. Yes, I think we actually went over some of these architectures. So I think a good place to start is LaNet 5. So you have your basic, like, I guess your standard CNN here with like 2 sets of convolutional and pooling layers. And then you have some fully connected layers at the end. So a good thing about this architecture is its simplicity. So there's only like 60,000 parameters. So this is quite insignificant compared to like industry standards. So this is definitely a good place to start.
Yeah, for reference, right? 60,000 seems like a lot. One of the models we talked about, GPT-3, it had 175 billion parameters. So 60,000 is less in machine learning.
Yeah, if you want to check out this article, I'm gonna try to link it in the chat.
Yeah. I remember the best way to do is always is to iterate. So make a simple model, test it out, try again. Don't try to make a 100-layer model right off the bat. That's probably not a good idea.
Yeah. Mm-hmm. A few things to keep in mind. A few conventions. You kind of just want to like try to implement your own things. I guess one of the good ways to get started, and you guys can look this up online as well, but it's usually better to start with smaller filters that pick up on kind of smaller features inside of your input images, and then kind of increase from there. And yeah, so general filter sizes, we saw during the CNN workshops, usually around 3 by 3 or 5 by 5, or 7 by 7 if you're looking for really like large and high level features. And the pooling filter sizes are usually smaller, usually 2 by 2 or 3 by 3. So yeah, try messing around with those hyperparameters and see what you get.
And give us some indication when you have like a model that compiles and the next cell runs essentially, like you can instantiate it. So give us some indication when we do that, and we can also fill in some rudimentary architecture in the meantime. Like our architecture is not optimal at all. It works. That's all. So y'all can do really well. I remember last quarter somebody got like a 99.9% accuracy, something like that, which is like super cool. So definitely a lot of scope here.
Well, actually, I didn't know that.
Yeah,
It's
it's
actually pretty
super cool.
impressive.
Mad. It's mad. Yeah.
So a couple of things to keep in mind always. Kernel sizes should be odd numbers. Don't forget to do padding. Don't forget to do pooling. That's kind of important thing to keep in mind for CNNs.
Yeah. One good way to kind of like understand how much padding you guys want to maybe apply. You guys have the opportunity, kind of like just take a look at your images and see, like the reason we have padding obviously is because we want to pick up on the features closer to the edges of the images. If most of the subjects of the images are closer to the center, maybe you might want less padding. But if there are certain features of the image that like important features of the image that do end up like closer to the edges, then you might want to have some padding so that your so while you convolve over your input volume, that you kind of pick up those features on the edges of the image as well. So yeah, take a look at your data set and figure that out if you want to.
Yep. Also remember that if you don't pad your images, they will reduce in size. So that's not always a good thing. So definitely keep that in mind.
Yeah.
And this is probably when the bugs are going to start popping up. So feel free to message us any doubts. Okay, so we have someone who's saying that they're a little shaky on the terminology. Anything in particular that you're missing out on? We
Yeah.
can go to a breakout room and talk about it as well if you like.
Yeah, if there's like a specific terminology, you can definitely we can definitely clarify. But I guess if you're just like lost in general, then I would recommend like, I guess, reviewing some of the slides.
Yeah, honestly, we could probably just stay in this room because I think like whatever information that we have to say can be useful for everyone.
Yeah,
Yeah,
whatever
unless-
you're comfortable with.
Yeah, unless
Yeah, exactly.
like you want us to debug for you. In that case, it will be helpful for you to share your screen, which is, I guess, easier to do in the breakout rooms.
Oh, so we have a couple of people who are saying that they're looking at the documentation and not knowing what each parameter means. And yeah, I see that happening. So
Yeah.
if you scroll
I mean-
right to the bottom, yeah, you want to pull up the documentation, Jenson?
Yeah,
If you scroll right to the bottom, it'll
let's go
actually show
through.
you a list of all the parameters that a model can take with a nice description of each of them. So it's actually kind of at the bottom. But remember, please don't try and set every single parameter. Most of the time, like the default ones are just fine. So just you want to scroll right to the bottom. Stride, padding. No, I think you can go further down, if I'm not mistaken. Yeah, there we go. So this is what you should look at. And is there any channel in particular that you're a little confused about? Okay, so we have a question. What does kernel size mean again? So you remember when we have the convolution operation, we have a small quote unquote square that we slide over the image, right? The side length of that square is the square is the kernel, and the size of the kernel means the size of that square, the thing that we convolve the image with.
I think the input and output dimensions are just like hard coded. Although, actually, let me explain this better. So for our first convolutional layer, the in channels is always going to be 3 because there's just the number of colored channels in the input image. But the out channel is actually like a hyperparameter because that's corresponds to how many filter you want to use for the convolutional layer.
Yeah. So another question, right? Should we pass in the input and output dimensions or just hard code? If you really think about it, right, a convolution doesn't care what the input and output dimensions are. It's just, if it's a bigger image or a smaller image, you're just gonna slide it over a little bit more. So the dimensions don't really matter except for, of course, the number of channels, the RGB or grayscale. So think about that when you're designing a constructor.
Jenson, if you want, you could probably like pull up the workshop slides from the CNN workshop, and then kind of like probably like it's probably better to like explain what kernel sizes and all those stuff mean.
Yeah, so give me a
I
second.
remember there's a really good graphic or a GIF. I think it was further down, yeah.
Yeah. I think, yeah, the site 29, yeah.
Yeah, so the filter size is just I guess the dimension of this yellow grid here. So another name for kernel size is the filter size. But I guess they're in the documentation, they're using kernel size.
Yeah, terminology is really wonky. There's often like a lot of debate across like the spectrum for what terminology for each aspect of models are. We have filters, we have kernels. It is a little weird, but yeah. Yeah, I mean, if you go a little further down, there's another like really nice. Keep going. Yep, keep going. Keep
Oh, you
going.
mean
No, keep going.
Oh, this?
Yeah, that one exactly. So you kind of see how this is working. We have these filter or kernels, I guess, as PyTorch calls them. And these are essentially what you're convolving over your 32 by 32 images. So yeah, I hope this gives everyone like a better understanding of what exactly kernels are and how they like fit in the context of like convolving over these input images.
Yeah, and if you have a specific question about some particular parameter, just shoot in the chat. No problem, you can answer specifics.
Yeah. And if you're still confused, please be free to like tell us. We can go over anything you guys want to help you guys like implement the layers of the model, because I would say like this is like this part of the project is probably the hardest because it requires like the most amount of like not just intuition but a lot of like back and forth and trial and error to get like the right fit of hyperparameters.
Yeah, if you really think about it, this is the actual PyTorch part of the workshop. Everything else is like fancy Python. So
Mm-hmm.
this it's completely fair to be a little confused in the beginning.
Are the out channels like the it's like you're doing the filter over it, and then what that outputs to, is that like the size of that thing that holds it?
Yeah,
So
exactly. So the out channel is like the depth of your output, or you can think it like that. So yeah, that corresponds to the number of filters that you're using.
yeah.
But
So you start with some input volume, and you end up with something else, which might be longer or shorter. And the depth of that is the number of out channels. And the reason is that is the depth is equal to the number of filters that you've used. So that's something to keep in mind as well.
Yeah, let me see if there's a picture here. Yeah, I think this picture is a nice illustration. So yeah, depth here is just the number of filters. So that will be your out channel if this is your convolutional layer.
Quick question: how do we know like what kind of convolutional layer we should use? Because I see that there's quite a few different options, and each one has like a 1D, 2D, or 3D like version.
Yeah, so that's important actually.
Yeah,
so
that's a great question. So I would encourage you guys to like read the documentation.
yeah, I mean we specifically were a little non-specific about that because that's important to think about which one is a good option.
Yeah.
Got it. Thanks.
Or you can look at the code snippets that we have provided here.
No, don't give it away, Jenson. It's a surprise.
wait,
No,
no.
I'm kidding.
Never mind. I think it's in the next workshop, so it's fine.
It's all open source. Is there a quick way to flatten a tensor? Yes. And
Yes.
I don't want to I don't want to give away the answer. So just literally Google flatten tensor, and it should pop up a nice little bit of syntax.
Actually, like multiple ways to flatten or implement like a flattening layer in your CNN.
Yep.
So feel free to explore all the different options.
Yeah, and make sure you get something that works with Torch. There's a lot of ambiguity sometimes. Some operations will work with NumPy, won't work with Torch, all that stuff. Better to just use whatever Torch recommends. So I'd recommend Googling the following, like you would in any job or anything. Just say flatten tensor Torch, and it should show up. Actually, let me try that out just to make sure. Yep.
Google is your best friend. That's all I can say.
So once you're done making your model, like the instantiated, right? What I'd recommend doing is like just seeing what the model contains. So you can see like a summary of what the layers are, and try evaluating it on some sample. So to make sure the forward pass actually works. We're not showing that here, but it should be literally model parentheses of some training sample.
Sorry, so just to be sure I understand this, each convolutional layer does each convolutional layer act on the original image, or do they act on the feature map that each
Yeah, they act one after the other. So the first one acts on the original image, that produces some output. Then then the next convolution layer acts on that output and goes on that way.
Yeah, so in this picture here, so the second convolutional layer takes in the output of the previous pooling layer as its input, and then it outputs another feature map, which is passed into another pooling layer. So everything in a CNN is like sequential. So that's a good way to think about it.
Yeah. And it's good you're all asking these questions. It's important to like make sure your understanding is solid. Try to have the previous workshop slides, I would say the previous workshop's notebook open nearby, and try and replicate something similar to that. Instead of linear, you might use some other function. Instead of, something similar to that. It's a very similar structure to that.
So this is a hint of which convolutional class that you should be using.
Yeah, okay.
There's a reason why I look for conv2D instead of conv3D.
Yeah. So I guess then just to explain
I'm
it,
not
right?
gonna give too much away though.
yeah. Just to explain it then, since we've revealed that's gone 2D, since it's a 2D image, we want to convolve over 2 dimensions, over the x-axis and the y-axis. So if you have something like a time series data, which is a 1-dimensional piece of data, then you're going to use a 1-dimensional convolution. And yeah, give us some indication when you feel like you have a couple of layers that would work.
Would we also use max pool 2D?
Yeah, that would be a good idea. Yeah.
Your intuition is right. Or maybe you read the documentation, so either way, that's really good.
That was a guess, but thanks.
So I did read some documentation, but if you have like a 3, so you have RGB values, so you have 3 input channels. Now, if you go to, let's say, 6 output channels, I'm trying to think back to the math that we were doing. What does that even mean? Is it like expanding it, or how do you double the number of channels?
So the number of output channels is simply the number of features that you've used. The number of kernels that you've used. So if you've used 6 kernels, and each of them is going to produce like a thin slice, what it's going to do, you're going to get 6 slices stacked up one after the other.
Mhm.
So yeah, you can think of a kernel as like a feature map, or not feature, like feature extractor. So with each like filter, you're kind of just like extracting some feature from your input space, and then the output of that filter is going to be like it's going to have 1 channel.
Got it.
Yeah, if you have like multiple like filters, you're just going to stack those the output of each filter into like a tensor. So that's what corresponds to your out channel parameter.
Okay, that makes sense. Thank you.
Yeah, no problem.
Do you want to give a hint for like how the first convolutional layer should look like? you know, just
Actually, I think it would be
to-
nice for them to figure this out, reading the documentation.
Yeah, but let's
But
give it
then-
a few more minutes and then let's see.
I
Yeah.
guess I can fill in the super class.
Yep. Right.
So hopefully everyone has got the super classes. So
Yeah, so note here, we didn't actually pass in anything to the constructor because we don't really need input or output dimensions. For a vanilla neural network, it's kind of important, but here we don't really care. We could if you want to design a model that way, but we have chosen not to.
so yeah, make sure you replace every like we've placed like a bunch of like nuns in our skeleton, so make sure you replace all of them.
Yeah, why is that a self? Yeah, CN, I think this should be just self, right? Wait a second.
And you actually have to pass in the
I think
name of your
yeah.
class.
Mm-hmm.
Wait a second. Oh, you're right.
I'm pretty sure, yeah.
Okay, there's actually a question. What is super CNN common self? So this is just calling the constructor of the superclass of CNN, which is nn.module. So you can actually look up the documentation here. So I believe it's torch.nn.module. So I think it's just the first option here. So yeah, here's like a template that you could use. So as you can see, you passed in the name of the class, which is model, and also a reference to this instance or a given instance of the class, which is self.
Yeah, and somebody's asking like, we didn't put anything the last time. Yeah, there's a, so Python 3 keeps changing it around, right? Before it used to be absolutely required. Now it's like, it'll work if it doesn't. We're just going to stick to it right now.
For padding, what would you like what would you put for that, like as a value?
That's a great question. So it's another one of those hyperparameters that you could potentially tune. So there's no one right answer, but it actually would depend on the kernel size.
Yeah, so one thing I'd highly recommend is looking into something called same convolutions, where you pad the image so that the image size doesn't reduce. And this is actually very, very important in real world applications. So you pad it according to the kernel size, but a specific value. So Google, actually put in the chat, same convolutions. And try and figure out how you can do that using PyTorch.
Yeah, I think we actually made a slide about it.
Right. I think this is a more question of like how much padding, right? It's like, yeah. So yeah, once you all figure out the answer, it'll be good to figure out the answer yourself. But there's actually a standard value that you should use when implementing CM convolutions.
But again, I think the same convolution thing is kind of like a design choice. So you don't have to stick to it, but it's just like a guideline that a lot of people use.
Yeah. Yeah.
Oh my
So,
gosh, please.
Yeah, remember to stay active on your notebook, otherwise it'll disconnect. Yeah. So while they're working, let me give you some theory, right? So when you perform a convolution, it's going to reduce your output size. That's a fact. So if you suppose like run 100 layers with no padding, in the end you're going to get left with this one dot in the middle. You're going to be left with no output, right? That's why we pad our input. Also, like they mentioned, to preserve the edges, the features on the edges, but also to make sure that we actually have some output remaining. Now, the way you preserve the output volume, make sure it's the exact same each time, is using CM convolutions. And of course, we do need to reduce our dimensionality eventually. And that's where max pooling comes in. Max pooling is how we reduce our dimensionality, and we don't often use it using convolutions. I mean, of course, you can invent your own style, but that's how it's usually done. Yeah, and does anyone have any other questions? How is everyone's progress right now? Okay, so we have a question. Do we need to specify softmax or is it assumed? So again, very good question. Go back to what we did last workshop. So PyTorch has a peculiarity where the softmax comes in at a later step. Try and recall where we did that last time. Again, I don't want to give it away completely, but you may or may not need to specify it within your class. Yeah, and if you don't get the answer to the previous workshop, just ask me and I'll tell you.
For the max pool, would like 3 parameters sound about right?
I think 3 parameters is definitely sufficient.
Okay, cool.
You can probably get away with less.
Yeah, I mean, it's completely a design choice. We don't know any more than you what the perfect parameters. So
Also, one more design question. So I remember I'd asked last time about if you, because like in the earlier workshop, we talked about repeating the convolutional and pooling layer. And I just want to make sure we don't reuse the same convolutional or pooling layers, do we?
So we definitely do not reuse the same convolutional layer. 100% no. Pooling layer you could, because they don't actually have any parameters inside them. It's your choice whether or not to do it. If you can keep that track of that, that's fine. To keep it simple, I'd say every time you need a new max pooling layer, just make a new one. It's simpler to keep in your head, I'd say.
Got it.
Also, hint, do not forget to activate because that's not included in your convolution. So figure out how to put your activation function in there. Otherwise, you'll get very different results. Okay, how's everyone doing? Did you all manage to get a few layers in?
I have oh, sorry, go ahead, man.
When we start thinking about linear ones, linear layers, do we just like it is the first in feature? Like how do we figure out how many the first
Yeah.
That was actually a great question. So there are actually a couple of ways to figure this out. The first way is just to do all the math, but that'll be actually a very good exercise, but it could be a little tough. So another way is to wait, no, I think it's flatten. So in the documentation for the torch.nn.flatten, there's actually like a code snippet here you can actually deploy. So you can actually like write some toy code here like this, and then like right after your flatten layer, you can check the size of your output. So this would be probably the faster way to figure like what the correct dimension should be.
Okay.
So if wait one sec. If it's like I was looking at the website that says the different architectures. If it's like 5x5 convolution, would that mean that the out channels would be 25?
No.
Actually,
you could specify
that's
that,
one
but
possible value, but like the out channel, I believe, should actually be the number of feature maps.
yeah, so it's the number of those 5x5 that you use. It's the 5x5 is just the size of that little square, right? The number of those 5x5 filters is the number of out channels that you'll end up getting. It's the depth of that final output volume.
Okay.
Yeah, the 5x5 affects like the face of the square, how like small or big that face is in the end. I think we can give it a few more minutes and then we can maybe implement a couple of layers. Make sure that everyone's making progress.
Yeah.
Yeah, I think after a few minutes, I'm gonna try to do the constructor, and then I guess let you guys implement the forward pass.
Yeah, the forward pass will be much simpler. So once you have that. Actually, since we started talking about pooling, maybe we can just put up the first convolution layer, Jenson. I think we've had a discussion about that. Yep.
All right, so I'm just gonna delete this line here because it's just a filler. So I'm just gonna call the first convolutional layer to be C1. So you can find this in torch.nn.conv2d. So there are a number of input parameters here, as we have discussed. The first one is the number of input channels, which should be 3 because we're dealing with RGB images. The out channel is actually a hyperparameter, so you can essentially fill in like whatever you'd like, but I'm just going to use 6. And then the third parameter is the kernel size. Again, this is a design choice, but I'm just going to use 5. So that would correspond to 5 by 5 kernel. So next parameter is the stride. So I'm just going to use the default value, which is 1. And the last parameter that I'm going to set here is actually going to be the padding. So I believe for a 5 by 5 kernel size, the correct padding for, I guess, the same convolution, or like sticking to the same convolution like convention would be 2.
Yeah, so it's always kernel size is always odd. So it's kernel size -1 over 2. That's always what the padding value should be for same convolutions, if that's what you want to do. Is everyone good with this line of code? Everyone has something similar? I mean, please don't worry about the hyperparameters, but of this structure.
So yeah, in principle, in the constructor, you're just gonna define like all the layers that you're gonna use, and then the for functions where you actually use them.
So I noticed there was pooling for, or sorry, padding for max pool. Why did you do it in that layer and not the next one?
Yeah, so that's a good question, right? So again, it's a design choice. So like I said, usually what we do, convolutions extract the features, and pooling helps us downsample. So that's usually what the convention is. And if you add padding to your max pool layers, what's going to happen is that you're going to end up like with something with the same size as the original thing, which isn't really good because you want to prioritize certain features, certain important values. Does that make sense?
Kinda, yeah.
Okay. Think about it. It's a design choice. We usually don't put it for pooling, but we almost always put it for convolution. There are lots of more deep reasons. I think we covered a lot of them in the workshop itself. So you can look at that as well.
Okay, sounds good.
Yeah, then I'm gonna wait for a few more minutes before, I guess, covering the first pooling layer.
Yeah. Remember, pooling is much simpler because it requires almost no parameters. Could everyone like check in maybe and like say how much do you think you've implemented? Because yeah, it's kind of difficult to gauge. Like, are you done with your constructor? Are you done with your forward? You know, your model is already training maybe, but some indication would be nice, just so we know how to pace ourselves. Okay, that makes sense.
Stuck a little on figure out the linear layer input dimension.
Yeah, so it's definitely a good exercise to figure out by hand, but you can also use the flatten thing. I don't know what to do next for the next conv. Okay. Yeah, so essentially what you need to do is specify how many input channels you want, which is equal to the output channels of the previous layer, and specify how many new output channels you want to do. So these are all design choices again. So just, I don't know, pick your favorite number and it should be fine. Like, don't worry about it too much right now. We can always tune it later. Just remember that the previous layer and the current layer should match up. That's all.
I guess if you're actually like stuck, or if you're actually having trouble like figuring out what the dimension should be, so a nice exercise to do here would be, let me create another cell. So you can do something like define like a custom model, I guess, it's just for testing purposes. And I'm just gonna paste in the layer that I've created or implemented, I guess. And then I'm just gonna create like a random tensor. I think it's torch.rand. And then I think the batch size is 16. Number of color channels 3, and it's 32 by 32. And then let's do output equals input. And output dot size. So yeah, like we expect, the size of the output is also 32 by 32 because we have set our padding to 2 to make sure the output of the convolutional layer is the same as our input. So yeah, this is an easy way to just like check the dimensions of the output of a given layer if you don't want to do all the math, which is a little complicated, I'll admit.
Yeah,
So yeah,
remember
hopefully that should solve any questions regarding to dimensions.
Yeah, just remember that the nn.conv2d is just a function like any other. So if you just type out this line of code, call it like you would call a function, it would also run. So you don't have to define your model itself. It'll just run as a function.
Yeah, I guess the upside of actually defining a model is if you have like multiple layers, it's just, I guess, a more organized way to do it.
Yeah, for sure.
Mm-hmm.
Could you please go to the input output thing one more time?
Yes. Also, this is in the documentation for flattening, I believe. Yeah, so it's right here. I'll jump back to here, I guess.
I think we can implement the max pooling layer, and then we can maybe wait a couple of minutes more before the linear layers.
Okay, so yeah. So max pooling layer is relatively simple compared to a convolutional layer. So I'm just gonna call this self.pool1, I guess, just because for the lack of creativity. So the class here would actually be maxpool2d as one of you have already pointed out. So let's pull out the documentation. So first parameter is the kernel size. So I'm just gonna pick 2 here. I think it's a pretty normal value. And the stride, I'm also gonna use 2. So for all the other parameters, you can just leave them as default. I think it should be fine.
There's a quick suggestion. Maybe we could actually pass them in as keyword args to make the parameters more explicit, just like so we can see them.
Yeah, that's a good idea, actually. Mm-hmm.
So I guess first thing would be padding.
Oh, no, I meant the ones we already have. You don't have to put anything else in there, I guess.
Oh, okay, I see.
Like size equals whatever. Yeah.
Kernel size.
Mm-hmm.
So,
we have a question. Do we need a relu layer? The answer is yes. Yeah, we definitely need a relu layer. So if you look at the PyTorch, the slides we did on CNNs, it's always convolution followed by some relu followed by max pooling, and that's important.
Okay,
yeah.
Documentation for relu. It's functional.relu.
Yeah, the reason it's important, otherwise you have like a linear operation, and we want nonlinearity to it.
think that's the right documentation.
What are you looking for, Jenson?
Relu.
Oh yeah, I can put it up.
It's force dot functional dot relu.
No, it's stars.nn.relu.
Oh, okay. Oh, there we go.
Yeah.
And remember, all these documentation sites have a little example almost always. So that's a good starting point. This is literally, you can copy paste a piece of code and build your own model of that. Does this make sense to everyone when we have the convolution layer and the max pooling layer? Is anything ambiguous so far? Okay, because in that case, then we can let's add another couple of layers, Jensen, and then we can do the linear layers after that. Since the next layers will be like the exact same as the previous ones.
Yeah, so the next layer here, I'm just gonna do another convolutional layer. So I'm gonna call this C2. So in channel here would actually be 6 because, yeah, that's basically that has to be the same as the output channel in the previous convolutional layer. And then the out channel for the next convolutional layer is actually, again, a design choice, but I'm just gonna use 16. And I'm also gonna keep the kernel size to 5 by 5. And let's see, also gonna use a stride of 1 and a padding of 2, just to adhere to the same convolution principle that we have been using. And I guess the second pooling layer is going to be exactly the same as the first pooling layer here. I'm just going to change the name.
Yeah, you don't have to
Yeah.
define another one.
Actually, can
Remember that.
reuse it, but I'm just going to
But
do it for clarity.
yeah, if there's any confusion about whether or not to reuse layers, it's always better not to use them than to, I'd say. Yeah, I think if you're good with these, then how is everyone doing on the linear layers? Is everyone good with that? Could you give some indication to us?
Yeah, actually, is everyone done with the constructor? Or are we still working on the constructor?
I was just kind of following along.
Oh,
Okay, that's fair.
that's fair enough.
Question on the max pool. So is there any reason we chose a kernel size of 2 and a stride of 2, or is that just arbitrary?
Yeah,
Yeah,
that's
again, it's-
arbitrary.
Yeah. All arbitrary.
Yeah, so it's definitely a design choice, but also you want to make sure, right? So pooling is going to reduce like the size. So if you let's go to like a graphic there in the slides, I don't know, any graphic you want to, not that one maybe, like where you see the layers,
The layers,
like
like this one.
the input volumes like reduce. There's one particular slide I'm looking at. Okay, it's fine.
This
So the
slide.
pooling essentially like kind of stretches out your input, so kind of makes it much smaller. So you don't want to reduce the size too quickly as well. So you don't want to have like a gigantic pooling layer.
Yeah, so like I think I set the kernel size to be 2 and the stride to be 2, so it'll do something like this. So we started with a 4 by 4 image here, and then our output is a 2 by 2. So I guess like the output of this convolutional layer is going to be 32 by 32 because we're using the same convolution principle here. So the output of this pooling layer would actually be 16 by 16.
Yeah.
Got it. And then one more thing. I see that we did like the convolutional layer and then the pooling layer twice in a row, but how come we didn't put a relu in between? Like for instance, after each convolutional layer, basically I don't know if we need to kill the neurons or not.
Yeah, it's a good
So
question.
that's
So
a great question, actually. So we're actually going to do this. We're going to add the relu activation function and the forward function.
yeah, so relu is not really a layer, right? It's just a function, something you do. So we'll put that in the forward propagation function.
But yeah,
Got
it's
it.
good that
Thank
you
you.
guys are thinking ahead.
Yeah, excellent, really good.
I have another question. I'm trying to run cross entropy loss and it says none type object has no attribute log softmax.
So I'm guessing what's happening is you have
So you have
called
to
it.
actually like change. Actually, it's kind of hard to debug, but like it could be the case where like some of these like values are still set to none. So I'm guessing that's what the error is coming from, but
There might be an error in your forward function.
yeah, it's actually pretty hard to
Potentially.
tell
So
without seeing the code.
yeah.
So that's what the breakout room is for.
Yeah, it's most likely in the forward function. But if you wanna drop in the breakout room, tell us. We can do that as well. And like, don't worry, we have a bunch of stuff left to do, so we're gonna continue this in the next workshop as well, and we can finish up our model then. I mean, models aren't implemented in an hour and a half, so really don't worry about it.
Yeah.
Yeah, I think the time estimate here might be slightly off.
Yeah, for sure.
So yeah, definitely take a bit of a grain of salt. Because we didn't actually like implement the model from scratch. So okay, so everyone done with the flattening layer. I guess I'll go through this flattening layer. So before you can pass the output of your pooling layer to your fully connected layers, you have to do this one step called flattening. I think as some of you have pointed out earlier. So there are multiple ways to do flattening. So the way I'm going to use here is just call this nn.flatten, which I think I pulled up the documentation earlier. So you can refer to this. So the default parameters here would actually, or the default value for the parameters here would work. So yeah.
Okay. I think we can, if they've got flattening, they should probably get the linear ones as well, because
yeah, I think the linear layers we did earlier, or we did last time, but I guess the tricky part is figuring out what the right dimension should be.
Yep.
Oh wait, no. Self dot. I guess I'm just gonna call it D1, which stands for, I guess, dense layer 1. So under nn dot linear, and then I actually did the math earlier. So the correct input dimension here, if you're using the exact same like parameters that I've been using, is just 1024. And then the output is again a design choice, so I'm just gonna use 120. And then yeah, I think the principle for the next fully connected layer is the same. So can do n.linear, but we're gonna use 120 instead as the input and 84 is our output. So again, the 84 here is the design choice. And finally, we have our output layer. So we take 84 as our input and then 10 as our output, because that is the number of classes that we have. All right, so any questions besides
Can
how
you
I got
explain
the 1024, I guess?
Yeah, I was gonna say, can you explain the 1024?
Okay. Yeah. So I think in this
easiest
case,
way
we
is
just.
to do the same test that I was doing earlier. So that's why I kind of introduced this. Let me, I guess, copy all the stuff here.
Yeah, you can pretty much just run your model and see what it spits out, or you could use the
You can do
the
math.
size method of the flatten class, or you could do it by hand. Whatever you like. So if you want to do it by hand, we have that formula in the slides, which you could use, which I think it's a good bit of practice.
It's a good exercise to do, like, if you're not like comfortable, I guess. Yeah.
Got it. And then the purpose of flattening, like how I know I found some models online, including on PyTorch. They had an example one, and they didn't flatten. So is there a particular reason we're doing that?
So if they didn't flatten in this particular way, they might have flattened using the view method in the forward class.
Yeah.
In the forward function, sorry. So one or the other, they're going to flatten somewhere, and there are a couple of different ways you can do it. This is a nice one because it actually says flatten, right? So when you're reading it, readability-wise, it looks good. But yeah.
Yeah, they use view.
Exactly. Yeah. So that's another way to do it. Yeah. So view is essentially reshape. So it's as good as a flatten. Yeah. Does this make sense to everyone? What's happening in the flatten and the dense layers? I don't know where everyone is at right now.
Yeah, is everyone good with the constructor of our CNN class? I think the forward function should be a little bit more straightforward.
Yeah, forward function is going to look almost exactly the same as the one we had
did
before.
last time. Yeah.
Yeah.
Mm-hmm.
Yeah. So quick check: is everyone good to move on to the forward function? I don't want to leave anyone behind. Okay, thumbs up. That's good. It's good. Okay, let's give it a minute.
Up. We have 2 thumbs up. Okay.
Okay. Then let's give it like. Okay, we can go on. I guess everyone seems to be good.
Yeah. So in the forward function, you're just like passing the input here, which is the x, through all the layers that you have here. So let me start with, I guess, the convolutional layer. So that would be self.c1, which I defined up here. And then I think some of you asked about the relu. So yeah, you would actually implement the relu here. So you pass in the output of your convolutional layer into the relu. And then after that, you would pass this into your pooling layer. So which I think it's pool 1. So yeah, this is just a really condensed way to do it. Feel free to do this over like multiple lines.
Yeah. Does this make sense to everyone, this line of code? Anyone have any questions about it? Because we essentially going to be repeating this like 2 or 3 times.
Yeah, so remember the capital F here is just torch.nn.functional, in case that is causing any confusions here. So is everyone good?
Okay, if everyone's good, let's implement the second layer as well.
Yeah.
It's the exact same thing.
Yeah, it's the same principle. So you can actually reuse the pooling layer here. I'm just gonna use a different pooling layer for clarity. But yeah. So keep in mind here, I'm updating X like every time I call like these sets of functions. You can also define another like variable if that is more clear to you, but yeah. Any questions?
Yeah, could everyone sort of indicate
feel
where
free
they
to
are?
give me a thumbs up if you're good. Yeah, actually, yeah, we're kind of running short on time here, so.
Why is it F dot relu? Yeah. So F we defined. Just want to scroll
so
up.
it's a torch.n.functional, and if you look at the documentation for, oh yeah, it's torch.n.relu. I guess this is the wrong relu.
It's a different
it's not the
relu,
right
I guess.
one.
Whoops. So there are actually like two different ways to do it.
Yeah.
So I guess I wasn't paying attention.
Yeah, you can just like control F and find the which relu, I guess.
Yeah, let me just look up relu. Okay, so it's down here.
There we go. Yeah. I think we got some thumbs up as well though. So we can try, let's try and get this CN implemented over here, and then we can do the training stuff next workshop.
Yeah, so the next layer here is our flattening layer. So I'm just gonna call it self.flatx. Set that equal to x. And then we've got some fully connected layers coming up here. So again, I'm gonna use relu as the activation function. And I'm gonna pass this through the first dense layer. And then in fact, I can actually copy this line of code because I'm lazy. Change this to D2. And our output layer is self.D3. So yeah, remember like you don't need the softmax function here because that is included in the cross entropy loss. So yeah, if you actually include a softmax function here, it'll actually throw an exception.
Yeah, so we have a question, right? What about this one? Is torture.nn.relu different? I'm pretty sure they both work just fine.
Yeah, I'm looking at the docs right now. They're pretty much the same, I would say.
Yeah, I'm not sure why exactly they have two of them. It's probably some deep reason, but I wouldn't worry about it too much.
Yeah, it's just in two different modules.
Yeah.
Which is kind of confusing, but
yeah.
So, does this make sense, everyone? The model implementation? Again, thumbs up would be awesome. And then if you have any questions, that'll be good too.
So the reason we chose an...
Oh, sorry.
No, I was just saying we can definitely go over it, go over like the entire structure of the class next time as like review when we begin our next workshop. But yeah, go for it. Questions and stuff.
So I just wanted to make sure the reason we chose the final output of 10 is because we have 10 classes, right?
Absolutely.
Yes, that's correct.
Yeah.
Any other questions?
Why are you not doing like self dot on the last two relu things before it?
So relu is not.
It's not like I guess it's not an attribute of the class here. So all of these layers here, I've set them to be like an attribute of the CNN class, but relu is actually in, wait, where's the documentation? Yeah, it's actually in this class, torch.nn.functional, which I think we gave an alias of capital F at the beginning. So that's why I'm doing f.relu.
Okay, that makes sense.
Cool. So let's try and instantiate our model and see what it throws up. I think if everyone's good with this class, like we just call our model in the next cell. Let's hope it. Is your runtime okay, Jenson? Okay.
Yeah,
No mind.
it's just
It's all
taking
good.
a while.
Yeah, it took a while. Yeah, so you get this nice like summary of your model with all your layers, your pooling, your flatten, really nice summary. And if you get an output like this, I think you should be in pretty good shape. So is everyone good with this? Okay, thumbs up. Any more thumbs ups? Any other questions? Debugging. Oh, we get an error. Okay. Cameron, you want to tell us what your error is?
Yeah, what seems to be the issue?
Yeah, what's the error message?
Make sure you run the cell containing class definition.
Oh, okay. So apparently in your constructor, you ask for a step size parameter, but don't pass that in.
Okay, actually, like time is almost up, so I'm just gonna stop the recording here.
Okay, wait, before we stop the recording, let's make something clear. So we're going to be continuing this notebook next workshop and make sure everyone actually finishes the guided project, right? So it's going to be a similar format, unless you all don't want it to be. So please fill out our feedback form. Tell us if this format works for you. If it doesn't, let us know. That's also really good. And yeah, next workshop we'll try and finish this up and have a classifier for our Spartan data set.
Mm-hmm. Honestly, if you guys want to keep going with the notebook, like go for it. See how far you can get. And if you do run into errors, like we'll be there next week to like look over everything and fix any issues you guys have. But don't just stop here. Obviously, feel free to keep exploring.
Yeah. So I would actually highly encourage you guys to try to like complete this notebook here before our next workshop, because like in the next workshop we're just gonna give you all the answers pretty much. So
yeah, but we'll continue a similar format for a bit at least. And also oh no, I forgot what I was gonna say.
Oh yeah,